Now that you've been introduced to complement, intersection, and union, we're going to add another layer over those operations on sets. In 2.3.3, we will study cardinal number problems. Now, here's the rule. Cardinal number of A union B equals the cardinal number of A plus the cardinal number of B minus the cardinal number of A intersect B. Let me remind you that the cardinal number, as denoted by this little n right here, represents the number of elements in that set. If we don't have cardinal number and we're calculating A union B, we just list the elements in the set. But with that n out there, we're looking for the number of elements in that set. So this rule is going to help us to count the number of elements in the union. One way that we can do that is in terms of the cardinal numbers of the individual sets. So to find the number of elements in the union, first we're going to count the number of elements in circle A. So if I look at this Venn diagram, I would look at all of the elements inside circle A and I would count those. Then I'm going to add it to the cardinal number of B. So I'm going to count all of the elements inside this circle, and that's the cardinal number of B. Now, did you notice when we did that, we would count the intersection twice, right? We counted those elements once with the cardinal number of A, and we counted those once with the cardinal number of B. Because I counted the number of elements in the intersection twice, I'm going to subtract the cardinal number of the intersection, and that's going to give me the number of elements in the union. Okay, let's put this into practice with example 5. An academic advisor found that 30 students are taking biology, 18 students are taking English, and 5 students are taking both classes. How many students are taking biology or English? Now look at the terminology. We're looking for the number of students. How many means cardinal number. And we want to know how many are taking biology or English. Remember, union goes with the word or, intersection goes with the word and. So to find the number of students that are taking biology or English, we'll say B for biology, E for English. We're going to count the cardinal number of B union E. Now, you can write the word or up there to remind you that union goes with or. Following our new rule, this is going to be the cardinal number of B plus the cardinal number of E minus the cardinal number of B intersect E. And remember, intersect goes with the word and. Feel free to write that in there in your work. So let's figure out these elements. We need to know how many students are taking biology. The cardinal number of B means how many students are taking biology. We can see right here from the problem, 30 students are taking biology. Next, we need to know how many students are taking English. And the problem told us 18 students are taking English. Now, remember, we counted some of the students taking biology, some of the students taking English, but there's some overlap there. The problem tells us 5 students are taking both classes. That means they're taking biology and English. So the number of students in the intersection then is 5. We counted those 5 students with the biology class. We counted them with the English class. So we need to subtract them off once in order to accurately count how many are taking biology or English. So we have 30 plus 18, that's 48. And 48 minus 5 is 43. So we could say 43 students are taking biology or English. The words are very important. When you read these problems, pay attention to the difference between and or. It will affect how you calculate the problem. Let's try another example. This example will help us to make sure we understand how to interpret the regions in a Venn diagram as well. Example 6, a group of 5th graders were asked if they primarily play outside or play video games after school. The following Venn diagram illustrates the results. Use the Venn diagram to answer the questions that follow. Who plays outside? So I'm going to look at my plays outside circle, and I'm going to list all of the names inside that circle. So we can say Willow, Canyon, Claire, and Wyatt. Who plays outside and plays video games? So I want to know which of those 5th graders are inside both circles, within the boundary of the play outside circle and within the boundary of the video game circle. And remember, means intersection. So I'm looking for the intersection or the overlap of those two circles. And I can see it right there. There's one student listed there, and that is Wyatt. He does both. He plays outside and plays video games. Next question. Who plays video games but does not play outside? So I'm looking for the students in the video game circle, but they are outside the play outside circle. So within the video game circle, but outside the play outside circle. Looks like we've got 2 students there. They would be Sierra and Ben. And the next question says, who does neither? So I'm looking for the students that don't play outside and they don't play video games. So they are outside both circles. Looks like we have one student, and that is Cliff. The next question involves a cardinal number. It says, find the cardinal number of O union G. Now, keep in mind, O, I am abbreviating the play outside circle. So the circle on the left is circle O, and G represents the video game circle. So I'm looking for the number of students in the O or the G circle. So they can be within the O boundary, they can be within the G boundary, or they can be in the intersection. And I'm looking not for what students are in the union, but how many, right? That little n means cardinal number, how many. So let's count those students. We have 1, 2, 3, 4, 5, and 6. So the cardinal number would be 6. We don't have to use our formula on that one. We can simply count it by looking at the Venn diagram.